Greetings, everyone. Today we're going to dive deep into the world of Oracle Net Services, the backbone of Oracle's networking infrastructure. Oracle Net Services is a comprehensive solution that manages all network traffic between Oracle databases and client applications, enabling seamless connectivity, data transmission, and communication protocol management. Imagine the Oracle database as a sophisticated postal system where the addresses are connection strings, the postal workers are network processes, the mail sorting centers are listeners, the delivery routes are network protocols, and the packages are data packets. This analogy will help us understand the core concepts and components of Oracle Net Services. First, let's explore the reasons why Oracle Net Services exists. The primary goals are network abstraction, connection management, and protocol handling. Network abstraction means that applications don't need to know the intricate details of network protocols. Oracle Net Services handles the complexity, providing location transparency for database resources. Connection management involves establishing and maintaining database connections, managing connection pools, handling session multiplexing, and providing load balancing and failover capabilities. Protocol handling refers to the conversion of Oracle's internal protocols to standard network protocols, as well as managing network packet sizes, fragmentation, and handling network errors and retransmission. The architecture of Oracle Net Services is composed of several key components, starting with the Oracle Net Foundation layer. This is the core component that provides the basic network functionality for database connections, acting as a framework upon which other networking features are built. The foundation layer consists of three main components. 1. Network session layer, responsible for managing database sessions, handling session multiplexing, and controlling session resource allocation. 2. Network presentation layer, handles data formatting, manages character set conversion, and controls data compression. 3. Network security layer, manages encryption, authentication, and access control. To understand these components in action, let's look at some examples. You can view session information by querying the vSession view, where you'll see details like session ID, serial number, username, program, and machine. Additionally, you can check the network encryption status by querying the Session Connect Info view. Next, we have the Oracle Protocol Support component, which enables OracleNet to use various network protocols for communication. It acts as a translator between Oracle's internal communication methods and standard network protocols. The most commonly used protocol is TCP/IP, Transmission Control Protocol, CHA Internet Protocol, which provides reliable, connection-oriented communication and supports both IPv4 and IPv6. You can configure TCP/IP settings in the sqlnet.ora file, such as specifying the allowed logon version, excluding or inviting specific nodes, and more. Other supported protocols include named pipes, a Windows-specific protocol for fast inter-process communication, and shared memory, IPC, the fastest protocol for local connections that only works on the same machine. Oracle Net Services also follows the OSI, Open Systems Interconnection model for network communication, with each layer having specific responsibilities. 1. Application layer, Layer 7, handles end-user interaction and manages application protocols such as SQL+, Oracle Call Interface, OCI, and JDBC drivers. 2. Presentation layer, Layer 6, manages data format conversion and handles encryption/decryption, with the two-task common TTC component playing a key role. 3. Session layer, Layer 5, establishes and maintains sessions, handles authentication, and manages session multiplexing. 4. Transport layer, Layer 4, ensures reliable data delivery, handles flow control, and manages connection establishment. You can explore the character set conversion settings in your database by querying the NLS database JA parameters view. Now, let's dive into the different connection types and use cases within the Oracle Net Services architecture. 1. Direct connections. Definition. A direct connection is the simplest form of database connectivity where a client connects directly to an Oracle database instance without any intermediate components. Client process, server process, dedicated or shared, and network connection. Configuration. Example, you can define a basic direct connection TNS entry in the tnsnames.ora file. Use cases. Simple client-server applications, development environments, single database connections, and applications requiring dedicated server processes. 2. Connection Manager, CMAN. Definition: Connection Manager is a middleware component that provides additional connection functionality, including multiplexing, access control, and protocol conversion. Components: CMGW, Connection Manager Gateway, CMAdmin, Connection Manager Admin, and the listener process. Configuration: Example: you can configure the Connection Manager in the cman.aura file, specifying parameters like maximum and minimum gateway processes, authentication level, idle timeout, and log level. Use cases: multi-protocol environments, firewall proxy, connection concentration, session multiplexing, and access control. 3. Database links. Definition: Database links enable communication between separate Oracle databases, allowing distributed queries and transactions. Components: source database, target database, database link definition, and network configuration. Configuration example: you can create private or public database links using the create database link statement specifying the remote user credentials and connection string. Use cases: distributed queries and transactions, data integration across multiple databases, performance optimization by reducing data duplication, and location transparency for remote data access. When creating a database link, you have two options. 1. Private database links, accessible only to the user who created them. Provide a secure, dedicated connection between databases, useful for internal controlled access to remote data. 2. Public database links, accessible to all users in the database. Provide a shared connection to the remote database, suitable for public or widely used remote data access. The benefits of using database links are numerous. They enable distributed queries and transactions, allowing you to query data across multiple databases as if they were a single logical database. This facilitates data integration, as you can combine and analyze data from different Oracle databases, reducing the need for data duplication. Additionally, accessing remote data through a database link can be more efficient than copying or moving data between databases, optimizing performance and reducing network traffic. Finally, database links provide location transparency, where applications can access remote data without needing to know the physical location of the database. This adds a level of abstraction and flexibility to your database architecture. When implementing database links, it's essential to follow best practices such as using private database links for secure connections, implementing appropriate security measures, and monitoring and managing database link usage to ensure efficient and controlled access to remote data. Additionally, you should consider the network latency and bandwidth when using database links, as they can impact overall performance. Now, let's shift our focus to another crucial component of Oracle Net Services, the listener. The listener. The listener is a core component of Oracle Net Services that acts as the mail sorting center in our database postal system analogy. It's responsible for receiving incoming connection requests from clients and forwarding them to the appropriate database instance. When a client application wants to connect to an Oracle database, it sends a connection request to the listener. The listener then evaluates the request, determines the appropriate database instance to handle the connection, and establishes the connection between the client and the database. The listener is configured in the listener.aura file, which specifies the listener's settings, such as the protocol addresses it listens on, the database services it manages, and various other parameters. Here's an example of a basic listener.aura configuration. Listener, description, address, protocol, TCP, host, DB server, port 1521, SID list listener, SID list, city desk, SID name, Oracle, Oracle Home, user 1 app, Oracle, product 18.00, DB Home 1. In this example, the listener is configured to listen on TCP IP protocol on port 1521 of the DB server host. It's also configured to manage the database service with the SID, system identifier, ORCL. The listener can be started and stopped using the LSN RCTL command line utility. You can use the following commands to manage the listener: lsnorkel start, start the listener; lsnorkel stop, stop the listener; lsnorkel status, check the listener status. The listener plays a crucial role in the connection process, as it acts as the gatekeeper between clients and the database. When a client wants to connect, it sends a connection request to the listener, which then forwards the request to the appropriate database instance, the tnsnames.aura file. Another important component of Oracle Net Services is the tnsnames.aura file, which is used to define connection details for various database services. This file acts as the address book in our database postal system analogy, providing the necessary information for clients to connect to the desired database. The tnsnames.aura file typically resides on the client machine, but it can also be stored on the database server or in a centralized location accessible to multiple clients. Part 4, Listener and Service Registration. The listener, the cornerstone of Oracle Net Services definition. The listener is a core component of Oracle Net Services that acts as the gatekeeper, receiving and managing incoming connection requests from client applications. Key responsibilities: listens for client connection requests on a specific network address and port, manages the initial handshake and authentication process, passes the connection to the appropriate database server process, handles load balancing and failover for multiple database instances. Listener configuration. The listener is configured using the listener.aura file, which specifies the network addresses, ports, and services the listener is responsible for. Example, listener.aura configuration, listener, description, address, protocol or TCP, host or DB server, port or 1521, SID list listener, SID list or SID desk or SID name or Oracle, Oracle Home or User 1 app, Oracle, product 18.00, DB Home 1. Service registration, dynamic versus static. Service registration is the process of informing the listener about the available database services. 1. Dynamic service registration, automatic registration of database services with the listener, handled by the LREG listener registration process. Reduces manual configuration effort. 2. Static service registration, manual registration of database services with the listener, configured in the listener.aura file, useful for advanced scenarios or when dynamic registration is not possible. Example, static service registration in listener.aura, SID list listener, SID list or SID desk or SID name or cell, Oracle Home or UO1 app, Oracle, product 1800, DB Home 1 or SID desk or SID name or PDB1, Oracle Home or User 1 app, Oracle, product 18.00, DB Home 1. Connection flow, client to database. 1. Client initiates a connection request. 2. The listener receives the connection request and performs the initial handshake. 3. The listener determines the appropriate database service and passes the connection to the corresponding server process. 4. The server process authenticates the client and establishes the database session. Troubleshooting, listener issues. Check the listener status using the lsnrctl command. Verify the listener.aura configuration for any errors or missing information. Ensure the listener is running and listening on the correct network address and port. Check the listener log files for any error messages or clues about connection failures. Part 5. Connection strings and TNS names. Connection strings, the address book of Oracle Net Services. Definition: connection strings, also known as TNS, Transparent Network Substrate. Names are the addresses used by clients to connect to the database. Connection string components. 1. Protocol address specifies the network protocol, host, and port. 2. Connect data identifies the database service or instance. Example, connection string. Description: address, protocol, TCP, host, DB server, port, 1521. Connect data, service name, ORCL. TNS names, centralized connection string management definition. TNS names are connection string definitions stored in the tnsnames.aura file, allowing for centralized management and distribution of connection information. Benefits of TNS names: abstraction of connection, details from client applications, easier maintenance and updates to connection information, improved security by controlling access to connection details. Example, tnsnames.aura entry, ERCL, ER, description, ER, address, ER, protocol, KER, TCP, host, ER, DB server, port, ER 1521, connect data, ER, service name for ORCL, your connection string resolution process. 1. Client application requests a connection using a TNS name. 2. Oracle Net Services searches the tnsnames.aura file for the matching TNS name. 3. The connection string details are retrieved and used to establish the connection. Part 6, Advanced Networking Concepts Connection Pooling and Session Multiplexing Connection Pooling, maintains a pool of pre-established database connections, reduces the overhead of creating new connections for each client request, improves overall application performance and scalability. Session multiplexing allows multiple client sessions to share a single database connection, reduces the number of physical connections required, conserves system resources, and improves scalability. Load balancing and failover load balancing distributes connection requests across multiple database instances, improves resource utilization and overall system performance. Failover automatically redirects connections to a backup database instance upon failure, ensures high availability and fault tolerance. Example, load balancing and failover configuration. It's order and ORCL, URC description, routings, address list, load balance are on, failover arrowing on, AD address, Huawei protocol, Huawei TCP, host indoors, DB server, Yomi port, Huawei served 1521, address Bombi Ferner protocol, Huawei TCP, host DB server 2, port Huawei 1521, connect data, our service name, shard ORCL. Advanced security features, encryption, secures data transmission between clients and the database, configured in the SQLnet.aura file, authentication, verifies the identity of connecting clients, supports various authentication methods, including passwords, Kerberos, and SSL TLS authorization, controls access to database resources based on user privileges, managed through database roles and permissions, example encryption configuration in SQLnet.aura. Got SQLnet, encryption server, required SQLnet encryption, client, required SQLnet, crypto checksum, server, required SQLnet, crypto checksum, client, in required. In conclusion, the Oracle Net Services architecture is a comprehensive and powerful networking solution that enables seamless connectivity, data transmission, and communication protocol management between Oracle databases and client applications. By understanding the listener, service registration, connection strings, and advanced networking concepts, you can effectively leverage the capabilities of Oracle Net Services to build robust, scalable, and secure database-driven applications. Thank you, and see you in the next video.